so that's that. Let's get on with what we were going to talk about today. And what I want to do is the first question in paper 1, which is solving for x. I was involved in some revision lessons with other schools recently, and it was actually really interesting for me how many children were unable to answer these first basic questions. So these are things that we should all be able to do. It's from grade 11. So I just thought we could spend a little bit of time today revising this. All right, so if we have a look at question 1.1, what do you guys think we should do with question 1.1? What's the next step? What do you notice? Okay, so Razan's messaged me. Right, so when you say multiply, Razan, do you mean multiply out the brackets? So get rid of the brackets. Okay. All right, so Nick, you've provided an answer, 100%. That's really good. Well done. All right, but a lot of people here, they want to multiply out the brackets. All right, so why is it not a good idea? Exactly, Nick, it is the zero factor law. Okay, so we have a factor, which is half x multiplied by another factor, which is 2x minus 1, and it's equal to 0. So if two factors multiplied together give 0, then either the one is 0 or the other one is 0. So what we should be writing here, we shouldn't be worried about multiplying the brackets out because it's equal to 0. So what we've got is either half x equals 0 or 2x minus 1 equals 0. So what's super important here, Matrix, is the fact that it is already equal to 0. If it was equal to another number, then you would have to multiply it out, get all the terms onto one side, make it equal to 0, factorize, etc., etc. But because it's already equal to 0, they've essentially done that step for you. All right, so all you need to do is now make both factors equal to 0 and take it from there. So if half x is equal to 0, then what would x be equal to? What would x be equal to? And what would x be equal to on this side over here? So half x equals 0 means x is? What would it be equal to? Quite right, Spoo. Okay, so it would be equal to 0. So in other words, I would divide both sides by a half, or I would multiply both sides by 2. It would also be the opposite operation. So x would be equal to 0. And here I would take the 1 over to the other side and then divide both sides by 2. Okay, so that's why it's out of 2 marks. 1 mark for x is 0. 1 mark for x equals a half. Okay, so we absolutely have to get that question correct. 1.2 says 2x squared minus 6x minus 1 equals 0. Correct to 2 decimal places. So what should I do in this question? Okay, correct. Correct, quite right. So what formula do I need? I need the quadratic formula, quite right. So the minute I read the words correct to 2 decimal places, the minute I see that, the question is telling me to use the quadratic formula. Okay, so use the quadratic formula. All right, so straight away, so I know that I have to use, I'm just going to make a little bit of space down here. So in 1.2, I've got to use the formula x equals negative b plus or minus root b squared minus 4ac over 2a. What is the rule with me using that particular formula? Do I have to write the formula down? That's quite right. Okay, so I have to show that I've subbed in. I have to show that I have subbed into the quadratic formula. Whenever I use the quadratic formula, I must show that I have subbed in, okay, irrespective of which section you are working in, okay? So I can go straight to that line where I write x equals negative b. So negative b would be equal to 6 in this case. Plus minus b squared would be negative 6 squared minus 4 times a, which would be 2. And in this case, c would be equal to negative 1 all over 2 times a. All right, and now I should have 2 answers for x. What are you guys getting? What are your solutions for x? Okay, so Razan says positive 3,16, 100%. Or negative 0,16. Lovely. Okay, and then we must just be, yes, Kamchelo, quite right. Okay, so just be careful here about your rounding. Okay, so Razan and Kamchelo, you rounded perfectly, but if they did take off a mark for rounding, this is potentially one of the places that they would do it. Okay, so 100%. So this is out of 3 marks, 1 mark for subbing into the formula, a mark on that answer, and a mark on that answer over there. Okay, good stuff. Well done, guys. All right, now the next question, 1.3. This is out of 3 marks, sorry, 5 marks, beg your pardon. So how are we going to answer this? What do they want us to do? Oh, it's Diana. Okay. Okay, Diana. Maybe what we must do, Neliswa, is just change Razan to Diana. Thank you. Okay, you'd square every term. Okay, Kamchelo says get rid of the root. Nick says square both sides. Is that the first thing that you do is square both sides? You guys are on the right track, but there's something that you need to do. There's something that you need to do before you can square both sides. Yeah, so Diana, what do you first need to do? Okay, because that's not the first thing, I'm afraid, Nick. That's the second thing that we're going to do. Yes, Diana. Okay, the first thing that we've got to do is we have to isolate the surd. Exactly, Valerie. So we have to transpose the 2. So step number 1 is isolating the surd if it's not isolated. So we're going to isolate the surd. That would be step number 1. Okay, step number 2 is squaring both sides. Okay, so if the surd is already isolated, then we can go straight to step number 2 and square both sides. But if it's not, we have to do that first. So in other words, we're going to take this plus 2 over here, over to the other side. So we're going to end up with x minus 2 equals root 2x minus 1. And then, as you guys had said, after that, we want to square the left and we want to square the right. So when we square the left-hand side, what do we end up with on the left? What would we get on the left-hand side? What do we have on the left, Matrix? We certainly do. We've got x squared. We've got x squared. What else do we have? That's lovely. Well done, Oratile and Adam. Lovely. Yeah, minus 4x plus 4. Okay, so a mistake, and you guys didn't make this mistake, but often with matrix, what they do here is they square the first term and they square the last term, and they forget that they're actually doing FOIL and that there needs to be a middle term, but you guys didn't forget to do that. So that's really awesome. Okay, so remember when we square a binomial, there have to be 3 terms. Okay, an x squared term, an x term, and a number term. Lovely. And then on the right-hand side, we would end up with 2x minus 1. What's the next step after that? What are we supposed to do? Taking over, quite right. So now we would have to transpose things. Okay, so this is getting it into standard form. Okay, there we go. So in other words, everything on one side and equal to 0. That's quite right. Okay, so we're going to end up with x squared. I agree, Diana. Minus 6x. Add 1 plus 5 equals 0. So there we go. That's standard form. After standard form, what's the next step in the process? We have to factorize. Quite right. Okay, so we've got to factorize our trinomial. So in this case, what would our factors be, matrix? 1 and 5. Okay, are Artile positive or negative? Yeah, both would be negative. Quite right. Okay, so it would be x minus 1 times x minus 5. What mistake have I made in the 1, 2, 3, 4th line? What mistake am I making? Can anybody help me? It's a very common mistake that we make in the 4th line. What have I not done? There we go, Amanda, quite right. Okay, very, very important. We're solving for x, so we have to say it's still equal to 0. Good stuff. Okay, good. All right, because if you leave off that equals 0 and there's an accuracy on that line, then you guys would lose that mark, and obviously we don't want that to happen. Okay, so remember, whenever you are solving for x, you've always got to make sure that your factors equal 0. So quite right, Diana, either x is equal to 1 or x is equal to 5. So the 5th step here is going to be solving for x. And are we all happy now? We're just going to move on to the next question. Yes, Camjelo, I quite agree with you. Are we happy? We're moving on to the next question. But Amanda, there's something I've forgotten. Diana, I've forgotten something. Sandisiwe, I've forgotten something. Camjelo, I've forgotten something. What have we forgotten to do? Okay. Not the parabola in this particular case, Diana, but you're right. In one of these, we are going to be drawing a parabola. Okay. And I think it's Spoo. Oh, no, Bokomoso. There we go. You need to test. Okay. So well done, Bokomoso. Because we squared both sides, it's this process of squaring both sides. We may have introduced a root that is not valid. Okay, we may not. It is possible for both of our answers to be valid, but then again, it's also not. So we have to go back and go and check. I know, hey, Camjelo. So make a big note. When you square both sides, remember to check. Okay, so here, number 6, when you square both sides, when you square both sides, remember to check. Okay, so check means you're going to test your answers, right? So we would go back to our original question, all right? And now we're going to go and just use our calculators. We don't have to do it any other way. We're going to use our calculators and we're going to sub in our answers. Remember, either x is equal to 1 or x is equal to 5. So now we've got to make sure that both of these balance the left and the right-hand side. So go back, use your calculator. Does 1 balance both sides? Is the solution of x equals 1 valid for both left and right-hand side? What are you guys getting? Do you know how to check this? Do you know what to do? So you're just basically working with the first line. So you can see here in the first line, we've got x equals. All right, so x equals this. So we know what x is, and we know that x is equal to 1. So on the right-hand side, we're going to take our calculator and we're going to press root 2 times 1 minus 1. Move 1 to the right, plus 2. What does that give us? Does it give us 1? Okay. Okay, so what we should be getting when we sub 1 in, quite right, Snegagoo, you should be getting 3. Okay, so does 3 equal 1? Definitely not. Okay, 3 definitely does not equal 1. So when we sub 1 in, we discover that it is not a valid solution, okay, because the left-hand side does not equal the right-hand side. So we put a line through the equal sign, or underneath we can write no solution, or we can write not applicable, right? Let's go and test the 5. So does 5 equal root 2 times 5 minus 1? And then remember to add the 2. Okay. So go and have a look. Because it's possible, very unusual circumstances, but it still can happen that both roots are not valid. Okay, do we get the same thing on both sides? We do. Okay, it's 5. So it's 5 on the left and it's 5 on the right. So we can see that 5 is indeed a valid root. Okay, so very, very important to go and check when you've squared both sides. Now we can see that this is out of 5 marks. So where would our 5 marks be allocated? Well, there's probably a mark for isolating the surd, squaring both sides, getting into standard form, and our factors. And then here, often what happens, this last mark would be on accepting the valid root and rejecting the invalid root. So yeah, that would be 1 mark there that you, if you didn't go and check, then you would end up losing. Okay, so often that's what the marks in these sorts of questions are for. All right, how's everybody feeling? Are we feeling good? Making sense? You can give us an emoji. How do you feel? Any questions? Good. Okay, cool, Nick. Good, Camilo. Good for him and the lady. Good. Yay. Nice. Well done, guys. Okay, so we are nearly there. We're almost finished with question 1, all right? And what we've managed to ensure so far is that we have got 10 out of 10. Every mark assists us with getting to where we want to be. Okay, now question 1.4. What sort of question is that? What are they wanting us to work with here? What is that thing called in 1.4? I love it, Diana. Love it. Yes, it certainly is. Yes, it's an inequality. What sort of inequality, guys? Specifically, what sort of inequality? Oh, Faheen, I don't know why you can't see the screen right now. Maybe try logging out and logging back in. Or Atila, we're not on to question 2. We're still on question 4.1.4. So the thing in 1.4, that's what we're talking about now. Okay, in 1.4. 1.4 is a okay, so I'm popping it into the chat. Okay, so 1.4 is a quadratic inequality. Yes, Lalita. Okay, so different to a linear inequality. Yes, less than or equal to, quite right. Okay, because it's a quadratic inequality, and I absolutely loved what just go back in. What Diana had said with parabola. Okay, because what we have on the left-hand side of our inequality sign, the 2x squared plus x minus 15, that is a parabola. Okay, it's a quadratic function. All right. So if we were to use just normal English, we don't have to use like maths English. What is this question actually asking us to do? What do they want from us? Could anybody explain that to me in just simple English? Okay, Diana, you're on the right track. Anybody else? Yeah, the size of x. Okay. Thanks, Nick. Okay, Luto, you're on the right track. We're finding critical values here. All right, so what I'm going to do is I'm gonna go down here, okay? And I just want to talk about this a little bit because I think it's so important for us to understand what this stuff means before we can begin to answer these questions. They're saying to us, for which values of x, is, and then the question is 2x squared plus x minus 15 smaller than or equal to 0. So what I want you guys to understand is that what I'm highlighting in yellow, this is a quadratic function, right? So in other words, if I was going to write a quadratic function, I would write it in terms of y or f of x. I would say y equals 2x squared plus x minus 15. Or if I used functional notation, I could say f of x is equal to 2x squared plus x minus 15. So what you need to understand is that this here on the left-hand side, this represents y. For which values of x is y, smaller than or equal to 0. Okay, so for which values of x is y smaller than, because of my sign here, smaller than or equal to 0. Okay, so if I want to find out the values of x for which y is smaller than or equal to 0, I'm looking for the values of x where my outputs y are going to be either 0 or they're going to be negative numbers. So when I draw this on the Cartesian plane, it ends up being a smiley face parabola. Why is it smiley face? Why is this a smiley face parabola, not a sad face parabola? Yes, there's one inequality sign. Yes, Diana. Okay, so the 2x squared is positive. So in other words, what I'm looking at specifically here is this number in front of the x squared. Because that number is a positive, that makes my parabola a smiley face parabola. And what I would do is I would refer to these values over here, my x-intercepts. So someone used the words earlier. My x-intercepts are my critical values. And the reason why they are critical values is because those are the values where x changes, y changes from being positive to negative. Okay, so the critical values are where y changes from being positive to being negative. Okay, so y will be positive when my parabola is above the x-axis. So in other words, in these regions over here. Y is going to be negative between my critical values. So in other words, that region over there. Okay, so they're asking us to solve for those values of x, where in this case, where y is smaller than or equal to 0. So what we need to do is we need to find our critical values, because those are the values of x where y changes from being positive to being negative or negative to being positive. And then from there, we can shade the correct region on the parabola and then answer our question. Okay, so now going back up here, all right? In fact, I don't know if going back up there was actually the best thing. Let's just stay here. We can do our answer here just as well. All right, so we would write down our equation. So 2x squared plus x minus 15 is smaller than or equal to 0. What is our next step? What do we have to do to find our critical values? Exactly. Now we need to factorize. And remember, when we factorize, we cannot leave off our inequality sign. So we're going to factorize. Here we've got 2x. Here we've got x smaller than or equal to 0. Now we need to think of two numbers. Okay, so which two numbers, when I multiply them together, excuse me, is going to give me 15? Which two numbers are we going to use here, matrix? Quite right. Okay, so where is, yeah, quite right. So where should 3 go and where should 5 go? And which one should be positive and which one should be negative? Okay, so Spoo says 2x minus 5. Okay, Spoo, let's do what you say. And here, what are you saying, Spoo? Okay, Luto says and 3. Okay, so like so. All right, and then what we can do at this point is just do a quick check by doing FOIL to make sure that when we multiply it out, we get what we have above. Okay, because there's no point in us proceeding if our answers are incorrect. So we would say 2x squared, and then we would end up with 6x minus 5x would give us plus 1x, and then negative 5 times positive 3 would give us negative 15. So you guys have done that perfectly. All right, what is our next step? Our next step is to write down our critical values. Good job. Okay, so this is not the solution to the problem. These are the x values where y changes from being positive to negative. So either, and you guys have said this beautifully, x is equal to 5 over 2, or x is equal to negative 3. Okay, it's not the solution to our problem. That is simply where y changes from being positive to being negative. So what should we do now? Good, Diana. I agree, that is the answer. But before we get there, all right, we have to show this either on a number line or by drawing a parabola. Okay, so if you choose to draw a number line matrix, okay, that is your x-axis. Okay, your smaller number will be on the left, your larger number will be on the right, because the x-axis is a number line, right? We know that this is a smiley face parabola, so we know that here it's positive, there it's negative, and there it's positive. Or our alternative is to draw what I had drawn up here. Okay, this is what I always do, is draw a parabola. I'm going to put my smaller number on the left, my larger number on the right. Now, the reason why we say that it's positive here on the left-hand side is because when x is a number that is smaller than negative 3, y is a positive number because it's above the x-axis. And same story on the right-hand side of here. When x is a number that's bigger than 5 over 2, your y values become positive. Okay, they are numbers that are above the x-axis. Between the two, so between negative 3, and 5 over 2, your y values are negative. So anywhere over here, we're going to have a negative y value. Where are they asking us to look? The inequality sign is directing us to where? You drew your parabola. Good. Excellent, Diana. Okay, so they're asking us to look where y is smaller than 0. Okay, so where is y negative? So this bit over here means we need to be looking over there or over here. Right, so between -3 and 5 over 2. How do we write between in maths? We have to write it as a compound inequality. We put the smaller number on the left, we put the bigger number on the right, and then we're going to go back and we're going to look at this. So where x is greater than or equal to -3, but smaller than or equal to 5 over 2. Okay, so in other words, between these two values. Okay, and that is our final answer in this case. When you are writing a compound inequality, so in other words, between a minimum value and a maximum value, your inequality signs always have to point in the same direction, and that's to the left-hand side. Otherwise, it wouldn't make any sense. All right, so what we are writing here means between. Okay. This question was out of, sorry, that one. It was out of 3 marks. Okay, so here there would be a mark for factorizing. There would be mark for either a number line or a parabola, and then there would be 1 mark on the answer. Okay. How are you guys feeling? Is this making sense? Everybody happy? Any questions? Well, Naledi, that's a very good question. Okay. And it depends on the nature of the question. So what I think we should do, Naledi, is let's do another example. Good, Diana. Good, Amal. Okay. So let's do another example. Okay, because what they could do, I mean, of course, we don't know what's coming at the end of the year, is they could do this to us. So let's say they say solve for x, and then they give us this. So x squared minus 8x plus 12 is greater than 0. What if they did that to us? Okay, so now they're not talking about the same region, right? They're still talking about a quadratic inequality, but they're saying to us for which values of x is y. So in other words, x squared minus 8x plus 12, where is y? Positive. So y is going to be positive above the x-axis. So with a question like this, same as with the one before, step number 1, you've got to factorize to find your critical values. So let's just put that on the side of here. Factorize to determine your CVs, okay? Because your CVs are where y changes from being positive to being negative. Okay, so now when we, whoopsie daisy, let's just rub that out. That doesn't look very nice. Okay, let's try that again. All right, so now we're going to factorize. So here we've got x, there we've got x greater than 0. So which two numbers are we going to use in this case, Matrix? What would go into the brackets? Okay. So 6 and 2 is correct. Naledi, both of these will be negative numbers. Okay, because our middle term is negative. Okay, and our last term is positive. So it has to be negative 6, and it also has to be negative 2 again. Remember, you can always check by foiling out your brackets. So x squared minus 2x minus 6x gives us our minus 8x in the middle, and negative 6 times negative 2 gives us our positive 12. Okay. It's okay, Diana. You're very funny. Okay, so our critical values are going to be where x is equal to 6 or where x is equal to 2 in this case. All right, yeah, 6 and 2. So now we're going to draw our parabola. Our x-axis, smaller number goes on the left. Bigger number goes on the right. Remember, our x-axis is a number line. So now they're saying for which values of x is y positive? Okay, for which values of x is y greater than or equal to 0? So here, y is going to be positive up there. Y is also going to be positive up here. So now our answer is no longer between. It's not between 2 and 6. Our answer is now when it's smaller than 2 or bigger than 6. How are we going to write that? Yes, with pleasure, Papalo. I've got a lovely one I can think of that we can do together, no problem. So we have to draw our parabola, and then we have to sketch or color the correct region. Okay, so how are we going to write this? So either where x is smaller than 2. So that's this bit over here, guys, where x is smaller than 2, or where x is bigger than 6. That's this part on the right-hand side. Okay, now Spoo, you can't do that. You're not allowed to do that, I'm afraid. You cannot write a inequality. So you cannot write this. Sorry, that way. So this is completely wrong. Okay, when you write these are called compound inequalities, and when you write them, the super weird thing with these guys is the fact that, you know, in English, I suppose with most languages, what we do is we end up reading from left to right. But with this, we actually don't read from left to right. We actually start reading in the middle. So what we want to do with this is we want to say x. So x is bigger than 6, but bigger than 2. That doesn't make any sense. Okay, so unfortunately, this is not correct. If we look at this region where we've sketched, okay, from this point onwards, going to our left-hand side, numbers get smaller. So that's why we say x is smaller than 2. Over here, from this 6 over there to the right-hand side, numbers are getting bigger. That's why we say or, where x is bigger than 6. Okay, so this is disjoint. It's not a continuous region. Right, and that's why we've got 2 separate inequalities to be able to answer this. Okay, so either way, the other way that you could do this if you wanted, and I mean, I don't like interval notation myself because I think it's confusing, but the other thing that you could do is you could say from negative infinity up to 2, union from 6 to positive infinity. That would be the other way that you could write it if you wanted to. Okay. So yeah, it's very important that you look at which way the inequality sign is pointing when you do the sketching. If they're telling you smaller than, if it's a smiley face parabola, so in other words, if the number in front of the x squared is positive, and they're saying to you for which values of x is y negative, then it's between your x-intercepts. But if they're giving you a smiley face parabola and they say to you for which values of x is y positive, then it's on either side. Okay. I think if it was Pabalo, someone here asked. Yes, Pabalo, ma'am, after this question, can we do an inequality when a is a negative number? Sure. So let's have a look at that one. Okay, so here we'll go for which values of x, and I'm going to do this. Let's do that. 1 minus 4x squared greater than or equal to 0. So, Pabalo, this is your question, okay? All right, so for which values of x is 1 minus 4x squared greater than or equal to 0? Cool beans. Now, Pabalo and everybody else, if they give you a question like this, where the number in front of the x squared term is negative, you have 2 options. Okay. Option number 1 is working with it as it is. Okay, so over here, as it is. Okay, so as it is means that we're going to leave it so that our number in front of our x squared term is negative. We're still going to factorize. So this is difference of 2 squares. So when I factorize this, it becomes 1 minus 2x times 1 plus 2x. So after I've factorized, I've got to write down my critical values. So what would our critical values be in this case? X equals what? What are our critical values matrix? No, Diana. Diana, what we're doing, I'm just doing an example with you. Pabalo asked for me to do an example where the number in front of the x squared term was not positive. Okay, so I'm not doing trig, I'm not doing the area rule. Oh, when are we going to do trig and the area rule? In the coming weeks, okay. Oh, yeah, sorry, Diana, I misunderstood you. We will do that. I'll have to go and have a look at my Notion document. But it probably a couple of lessons from now. Okay, Diana, we'll go over the area rule, the cos rule, and the sine rule. Okay, so a lot of you are saying your critical values are where x is equal to 1 over 2, which is correct, or where x is equal to negative 1 over 2. No problem, Diana. Okay, I don't mind you telling me that there's certain things you want to cover, and then I can make sure that those are in our lessons. Not a problem. All right, so this is a sad face parabola matrix, isn't it? Because the number in front of the x squared is negative. Remember, on our number line, the smaller number always goes on the left, and the bigger number always goes on the right. So over here, they are saying to us for which values of x is y, and here it's greater than or equal to 0. So we're sketching above or below the x-axis. What region are we looking at? Above x-axis or below x-axis? Above, quite right, Spoo, quite right, above. Okay, so we're looking at this part over here. Okay, because this is the part where y is positive above the x-axis. All right, so is this a between, or is it smaller than this or bigger than that? What sort of answer is it? Is it a between answer, or a bigger than this or smaller than that answer? So is it a between or smaller than or bigger than? It's a between, quite right. Okay, it's a between. Good job, guys. Okay, so it's a between. So that means we have to write it like this. X in the middle. Okay, greater than minus 1 over 2. Smaller than 1 over 2. Were we including our critical values in this case? Yes, we were. So I just need to remember to go and put those in as well. Okay, lovely. Well done. Nice job, everybody. Okay, so that is option number 1. Okay, so let's just write here. Option 1. Okay, so Pabalo, this is option number 2. Okay, so option 2 tells us that we can multiply through by negative 1. All right, so I'm going to write here, multiply every term by negative 1. So Pabalo, if I multiply every term by negative 1, what am I going to end up with? Multiplying every term, so in here, multiplying every term by negative 1, what will I get? So minus 4x squared is going to become positive 4x squared. Plus 1 is going to become minus 1. What's going to happen to my inequality sign? Okay, so Kinsani, we're just considering a different way of doing this. This is a different way of getting to the answer. Okay, so we could do it option number 1, or we can do it by option number 2. All right, so what happens to my inequality sign when I multiply by a negative? What happens to my inequality sign when I multiply or divide by a negative matrix? The sign has to change around, absolutely. Okay, so instead of this being a greater than or equal to, it's now going to be a smaller than or equal to. Okay, so the inequality sign has to change direction, quite right. So the reason why this happens is because of this. Let's say if I make a statement here, so I say 6 is smaller than 10. That's a true mathematical statement, right? But if I divide the left-hand side by -2, I would end up with -3. If I divide the right-hand side by -2, I would end up with -5. If I keep my sign in this direction, I'm saying that -5 is bigger than -3. Is this true? Okay, is this true over here? Is -3 smaller than -5? No, not true. Okay, not true. Okay, at all. Okay, and that's why my sign, the minute I divide or multiply by a negative, it has to change round. So that's why this sign changed round. Then it would go through the same process matrix. Factorize. Find my critical values. So x is equal to 1/2 or x is equal to -1/2. Can you see I've got the same critical values as I had before? The difference is now is that instead of me drawing a happy for sad face parabola, now I'm drawing a happy face parabola because this is now a positive number, smaller number on the left, bigger number on the right. Now we're saying between which two values of x is this smaller than or equal to 0? Okay, so again, this is going to be a between minus 1/2 and 1/2. Y is negative. Okay, that's fine, Kamogelo. That's fine. You don't have to do it this way if you don't want to. I'm just showing you that you get the same answer. So x is greater than or equal to -1/2, but smaller than or equal to 1/2. Okay, you get exactly the same answer. Right, you prefer option number 1, Kamogelo? That's what you go with. Okay, I just wanted to show you both options.